Hello, how are you? All right, good. So the setup is complete. I can see that the facial tracking is happening. Yesterday was our first video. Today is our second video, and I am going to be. Last time I gave you a bit of a run around about the workshop. I introduced you to some of the tools that we have, some of the machines that we have. Thickness planer, the jointer, the PantoRouter, the cabinet saw, the Makita band saw, and the router table. The miter saw is missing because it's in the other room where we're still setting up the whole, I'm setting up the whole thing. Today I'm going to talk about something a little different and a little exciting. It's a very unique tool. I think somebody came up with it in the US. I've seen his, don't know the name, seen his videos. A young fellow, he came up with it, and I think it's really taken over the world. It's for joinery purposes, and it's that machine over here. It's called the PantoRouter. Now, the PantoRouter, it's a joinery tool. Basically, what it does, it's got a. Let me show it to you. Here it is. This is a PantoRouter. It's quite well, it's doesn't have much, but if you think about it, it's actually a bit. It's a little bit of a genius tool because what it does is it uses the router, which is a very old technology, very old machine that the woodworkers have been using forever and ever, puts it in this contraption, and what it does is that you can move it around to create template based. This is a template at the top, and you can create mortise and tenon. I did something yesterday. I created one with the help of this, and this is the experimented one. But here you can look. This is the mortise, and here's the tenon. It was created by the PantoRouter, and you can then just simply put it in place. And so it helps with joinery. It's a very good joinery machine. And there's a bit of a challenge that I was having yesterday. My challenge was that the machine came with a 12 millimeter 12 mm, with about half an inch bit, spiral cutting bit, but it broke, and I was using it. I made a mistake. I pushed it too hard, and as you can see, it snapped in the middle right there. It was a very good bit, but I don't know why I did it. I mean, rather than just going left, right, slowly, gradually, I went, and then instead of pulling it back up, making a few other grooves and then connecting all of them, I went this, and then I did that, and then it snapped. So here you can see, very strong carbide thing, but well, when your machine is turning at 20,000 plus RPM, and you do something stupid like that, this is the result. So now I did not have another bit, and the result was that I ended up using one of my older ones. Now the problem is it was a 14 millimeter bit, and the way this PantoRouter works is that just hold on for a second. Here we go again. So the way the PantoRouter works is that it's got three different elements working together to make a certain mortise, certain size mortise, and the tenon. And those three elements that work together is the size of the template, size of the bearing, and then the size of the bit. They're all in correlation. So if you change any one, you'll have to do a bit of an adjustment with the others as well. Now, what the PantoRouter came with was this template. This was a template originally here, right? It was like that. Now, the size of the template is 30 millimeter. The bearing is 28 millimeter, and the bit was the one that broke was 12 millimeter. So that's all in correlation with each other. And when these three are based, when you have a 12 bit, 28 bearing, and a 30 template, you've got a perfect mortise and tenon that you need. Now, if you change one, which I did, change it from 12 to 14, I had to make amendments here as well. Now, either I will have to increase the bearing size from 28 to 30, or I'll have to increase my template size from 30 to 32. So what I decided to do was make a new template. And if you look at it, this template, which I made out of walnut, it's actually, you won't be able to see, but it's a little bigger than this. This is a 30 this is a 32 You can maybe actually, you can make it out. You see? There you go. So this is larger than this. And the reason is that we need to make it correlate to this bit, which is 2 different to the previous one. And that's the template that I created. Now today I'm going to make another one and show you how it's done. It's not that difficult, it's easy, but all the people out there who have PantoRouters and are struggling with it, this is the simple way of doing it. And let me show you the correlation and everything between this three factors. So for example, that you want to make a mortise which is 14 big, right? What the way the three elements that are working is, number one is so for example, the mortise size of the mortise, bit size, template size, and the bearing. So they all work in correlation with each other. So now imagine that you want to make a 14 a mortise. The formula is very simple. The 14 mortise, because the bit rotates around the mortise. Let's imagine that this is a bit. Let me make a circle, and it goes around like this around the template. Let's imagine that this is the template. So the way you calculate is you take the 14 the size, and then half, because it's going in a, it's going in the circular motion. You take half a circle of this and half a circle at the top, half a circle at the bottom. So you have because I have a 14 bit, I will have to do 7 plus 7. So that gives me 28. With the 28 is the bearing size that I will need in order for me to do a correct thing. And if I want to find the template size, it's very simple. 28 will have to be multiplied with another 20, make it double. So you do 56, and you minus the bearing size, which is 28. So your template, this thing is getting hot, will be somewhere around, I think it comes to 32. Right? Now, here was my problem. This is the template size. That's the bearing size. So if you are making a 14 mortise with a 14 bit going in a circular motion around the template, creating the mortise, you'll have to take half 7, basically it's 2 because it goes around. So you take 7 and 7, that is half of the bit size, and plus that gives you the bearing size. You need a 28 mm bearing, which I already had. The problem was that my template was 30 mm, not 32. Now, because of that, when it was going around, it wasn't giving me the correct mortise and tenon size. My mortise and tenon wouldn't fit. They had a gap in it. And I'll show you what I mean by that, because I made a few samples and they wouldn't fit. So for example, this is something that I made at the time when I was using here we go. This was a mortise that I created, this one, and then I created the tenon, not that one, this one, sorry, and it wouldn't fit. Well, this one fits. No, this is not the one that I was working with. I think I was, oh yeah, here we go. This was the mortise that I created. This was the mortise that I created. And then the tenon that was being made was this one. Now, if you look at it, it's very loose. And the reason for that is because we were using a 28 mm bearing, which is this one, and I did not have a 30 mm bearing. Or we were using a 30 mm template, we were not using a 32 mm template. And the result was that we were not able to get the correct mortise and tenon. My bearing was 28, but my template was 32, was 30. It wasn't 32, and I needed a 32. And that's the reason why I built a new template, this one. So that's actually the correlation. I hope you all understand. It's actually quite easy once you get your head around it, but it can be a bit tricky as well. I mean, it's not that simple.